Think about this for a second. Right now, where you are, someone somewhere else is just seeing the sun come up. Someone else, it's the middle of the day, sun blazing, and for another person, it's pitch black night.
And the stars overhead. They're different, too, depending on how far north or south you are.
Exactly. So is the whole universe shifting around, or is it, just us, our spot on this spinning planet, changing our view?
That's the core question, isn't it?
Yeah.
And as we talked about before, Aryabhata gave us this really powerful model centuries back of a spherical Earth that rotates.
Right.
And what's really fascinating now is looking at, well, what does that mean in practice? What are the real world effects you'd actually see?
Yes. Welcome back to the deep dive. We're taking these big ideas and really unpacking them. So building on Aryabhata's spherical spinning Earth model, our mission today is to see how that idea explains why the sky looks different depending on where you stand.
And what we're diving into is Golapāda, specifically verses 13 through 17. They lay out these explanations pretty elegantly, and they're still, fundamental today.
Okay, so the practical stuff, like how our position east-west, our longitude affects our time.
Time zones, essentially.
And how our north-south spot latitude changes which stars we see.
Yep. And also this subtle thing called horizon dip, seeing the Earth's curve.
Oh, right. And even how long a day feels depends on where you are.
Exactly. The relativity of it all. And we'll use a few of Aryabhata's Sanskrit terms from the Golapāda to guide us.
Okay.
We have Laṅkā, Yamakoṭi,
Romaka,
Siddhapura,
Akṣa, which is latitude,
Akṣa,
Ujjaini, and Dṛkchāyā for that horizon dip.
The Dṛkchāyā. Okay, context set. Let's start with time then. It governs everything.
Yeah.
How did Aryabhata explain why my now isn't your now if we're far apart? Well, it flows directly from around Earth spinning eastward.
Yeah.
As it turns, different longitudes face the sun one after another.
Makes sense.
And Aryabhata nailed this in verse 13 of the Golapāda. He used 4 key cities right on the equator as examples.
Ah, yes. Laṅkā, Yamakoṭi, Romaka, and Siddhapura. Like taking a snapshot across the globe.
Exactly. He gives us the verse, Udayo Lakuyam, basically saying.
Let me guess.
Go on.
When it's sunrise in Laṅkā.
Yes.
It's sunset way over in Siddhapura.
Precisely. Sostamaya Savitur Iva Siddhapura.
And midday somewhere else.
Midday in Yamakuya, Mathyano Yamakuya.
And midnight.
Romaka Vihayot Hatrasat. Midnight in the Romaka region.
Wow. So he didn't just say time is different. He saw it as different views of the same solar event happening simultaneously across a spinning globe.
That's the key insight. The Earth turns 360 degrees in about 24 hours, right?
Roughly, yeah.
So move 90 degrees longitude east, and you're about 6 hours ahead in terms of where the sun appears. So Laṅkā sees dawn. Yamaku, 90 degrees east, it's noon. Siddhapura, 180 degrees away from Laṅkā, sees sunset. And Romaka, 90 degrees west of Siddhapura, it's midnight.
So now is totally relative to your longitude. That's fundamental.
Absolutely. It's the bedrock of modern time zones. I mean, the formal system is much later, but the principle, it's right there.
Dividing the world into strips with agreed upon local times.
Yeah. Essential for coordinating anything global. Travel, business, calling relatives. He grasped the core logic just from understanding a rotating sphere.
Okay, longitude sorts out the clocks. What about the view upwards? How does moving north or south, changing latitude, Akṣa, affect the stars we see?
Well, your latitude changes your viewing angle onto the whole celestial sphere. It dictates how much of that sphere is actually above your horizon.
So some stars always stay up, some rise and set, some you never see.
That's it. And Aryabhata uses Laṅkā on the equator and compares it to Ujjaini, which is north of it, to illustrate this.
Right, in verse 14, how does he set that up?
He describes their positions relative to the Earth's size. Stalhamadya Laṅkā. He says Laṅkā, the equator, is a quarter of the Earth's circumference away from the land-water midpoint, likely the North Pole, so 90 degrees.
Okay, equator is 90 degrees from the pole. Makes sense.
Ujjaini Laṅkā is Takaturasha Samatarata. And Ujjaini is north of Laṅkā by 1/4 of that quarter span.
1/4 of 90 degrees? That's 22.5 degrees north latitude for Ujjaini.
Exactly, which is remarkably close to its actual latitude, around 23 degrees north.
How did he likely figure that out?
Well, the verse doesn't say, but almost certainly using a gnomon like a sundial post, measuring shadow lengths at different times, especially solstices. It's clever stuff.
Ancient tech. We should maybe cover that sometime.
Definitely. But the main point here is, move north or south, and your whole relationship to the sky changes fundamentally.
And he pushes this idea to the extremes, right? Thinking about the North and South poles.
He does in verse 16. He describes these completely different views. Devapeshanti Bagolardam. He says the gods at the North Pole see the northern half of the celestial sphere.
Okay.
Udak Rusistisavyam. Always above the horizon, circling clockwise.
Wow. No rising or setting, just endless circles.
Exactly. And then the spirits at the South Pole, Ardhatidi, Apasavegatada de Kanchavamukhi Prito, they see the other, southern half, circling counterclockwise.
A completely mirrored yet equally strange sky.
Right. For someone at the North Pole, the North Star, Polaris, is practically straight up. Everything pivots around it, parallel to the horizon. Circumpolar.
And the same at the South Pole, just with the southern stars.
And for us in between, we get a mix. Some stars rise and set. Some near the celestial poles stay up all night circling. How much of each depends purely on your latitude?
It's really something that he could visualize these alien skies just from the geometry of a spinning sphere. Shows the power of the model.
It really does. And knowing how the view changes is still critical. Think satellite orbits, planning where ground stations need to be, even old-school celestial navigation.
You also mentioned something about the relativity of time cycles, beyond just daily sunrise-sunset.
Yes, that's verse 17. He kind of expands the idea of what a day means, connecting it to different places and contexts.
Yeah.
Ravivarto Devapashanti. He says the gods, our North Pole observers,
Yeah.
they see the sun continuously risen for half a solar year.
Half a year of daylight. Wow.
Tada Pritat. And the same for the spirits at the South Pole. 6 months of sun, 6 months of night.
Because of the Earth's tilt as it goes around the sun.
Exactly. It's a direct result of the geometry. Then he says, Shashimasartai Pitaro. The ancestors on the moon see it for half a lunar month.
Huh. Like daylight on the moon lasts for weeks.
Roughly, yeah. Related to its rotation matching its orbit. Then he brings it back home. Kodinartham Iamanija. Humans here, not at the poles, see the sun for about half a civil day, our familiar day-night.
So the length of daylight isn't fixed at all. It's totally relative to where you are in the cosmos and how things are moving.
Precisely. It puts our 24-hour cycle in perspective, doesn't it?
It really does. Okay, and there is one more thing. Horizon dip. Dṛkchāyā.
Ah, yes. Verse 15. This is neat because it's direct, observable proof of the Earth's curve, even if it's subtle.
So the horizon isn't a perfectly flat line cutting the sky in half.
Nope. If Earth were flat, you'd see exactly 180 degrees of sky from level ground. But Aryabhata points out, basically from level ground, you see slightly less than half the celestial sphere.
Less? Why?
Because the Earth's curve dips the horizon down slightly below a true horizontal line from your eye.
Ah, so the curve blocks a tiny bit right at the edge.
Exactly. And conversely, Ardhavamichana, the half hidden by the Earth, is slightly more than a hemisphere.
By that same small amount.
Right. It's proof the ground beneath you isn't flat, but curved away. You notice it more from, say, a tall building or a ship's mast looking out to sea.
Another piece of evidence for around Earth that you can actually potentially see for yourself.
And something astronomers or navigators using sextants have to account for. So next time you look at the horizon, remember Aryabhata, it's not quite flat.
It's just fantastic how all these different things, time zones, the changing stars, those super long polar days, the curved horizon, they all just click into place with that one core idea. A spherical, spinning Earth.
It's a unifying principle. And these ideas, they didn't just stay in ancient texts. They echoed right through to today.
We already touched on time zones being based on that longitude idea.
Absolutely. And latitude and longitude themselves, still the basis for all our mapping and navigation. GPS relies on knowing these precise coordinates on the sphere.
And knowing how the sky changes with latitude.
Right.
Vital for satellites.
Right. Vital. Planning orbits, communication links, and even things like VR astronomy. If you want to simulate the night sky from Mars or from the South Pole.
You need Aryabhata's principles about how perspective changes things. Down is different, day length is different, the visible stars are different.
Exactly right. These consequences of Earth's shape and spin are baked into how we understand and interact with the cosmos, technologically and conceptually.
It's been really illuminating seeing how Aryabhata connected the dots between his model and these real-world observations. A rational explanation for so much complexity.
It really underscores the power of that shift to thinking of Earth as a sphere in motion. It wasn't just abstract geometry. It explained the world people experienced.
Yeah. Which, thinking about it, brings up the next logical step. How do you go from understanding these concepts to actually measuring things precisely?
That's the perfect bridge. How did astronomers like Aryabhata quantify star positions or track time accurately from their specific spot on Earth?
Ooh, I like where this is going. That's for our next deep dive, episode 28, isn't it?
It is. We'll get into the observer's own reference frame concepts like the meridian, the prime vertical, tools for pinning down directions in your local sky.
And you mentioned trigonometry before, using signs.
Yes. We'll explore how Aryabhata used trig, likely derived from those sine tables we discussed, to calculate things like a star's altitude, the time of day or night, even determining latitude.
All from measurements, like using shadows.
Exactly. It's where the measurement meets the model. Practical, ancient astronomy in action.
Okay, that sounds fascinating. The intersection of math, observation, and this ancient undericing. Definitely don't miss that one.
It's digging into the how-to of ancient astronomy, turning the grand model into numbers and predictions.
Fantastic. Well, please join us next time as we continue exploring Aryabhata's incredible work. Until then, keep looking up and maybe notice that little dip in the horizon.
Keep pondering our place on this spinning sphere.